Alright, down and dirty. Finals coming up this morning. Let's go. This is what we're working towards right here. And what I've uploaded is this file, which is our base file. All my interfaces are set up. Step 1, configure all usable interfaces. So that's done. And I have all the code for that here. We're going to go down to step 2. Add PCs and servers and give IP addresses. So we've actually done that already. If you come here, you can see this already has an IP address. So now step 3 is to configure OSPF routing protocol on router 1 and router 2 using process ID 10. We've done that a million times before, so FYI, this is router 1, this is router 2. I know it's hard to see because of the way I've got things, but this is router 1. This is the code to do that. I've already got it written. You guys should know by now how this operates. Router OSPF. I'm combining step 3 and 4. Why? Because step 4 is assign router ID to router 1 and router 2. This matters because we need to do that right away after we do router OSPF 10. So I'm going to go ahead and copy this, right click, and actually I need to be enable config T first. We're going to right click, paste, and there you go. That's all in there, done. So I've got 4 networks on router 1 and I've got 3 networks on router 2. Alright, so router 2, click on that, CLI, hit enter, and we're going to go ahead and copy this in. Easy peasy lemon squeezy. Also, I need to do enable config T, make sure I'm in config, right click, paste, boom, there we go. So that's taken care of. That's step 4 and 5. So I'll put the router ID. I've also set up OSPF. So now if I come in here, I should be able to ping any of my other compatriots. So we're going to ping this computer right here, which is 172.16.12.96. 98. There you go. I can ping it. So we're good. Step 5. Configure router 2 to be the DR by setting OSPF priority. OSPF, right? Alright, so picking back up where I screwed up at. I did this earlier and didn't pay attention. Essentially, we have to use the interface that's between the 2 routers, right? So that's gig 0/0 on router 2, and it's gig 0/1 on router 1. I was using the incorrect interface, so I went back and removed it. So now the correct format is interface gig 0/0, IP OSPF priority 200, and then did the same thing, clear OSPF process, and then we need to come back in here and rectify this. Okay, so let's go back to 2. We're going to config T, interface gig 0/1. No IP OSPF cost 20, and then we're going to go right back into gig 0/0. Let's fix that again. So we can have nice things. Okay. So we're going to say no, and then we're going to do 10. Default is 1. We're going to make it 10, and then exit. Do readback. Okay. Let's change this right here back to 10. Anyway, all that said, that's actually the correct thing-a-majig that we're doing. So, and that's all being done on router 2. Router 2 for me is this left side. Again, this was given to me by Mr. Sharif yesterday, so I'm assuming that's pretty close to what we're doing. One thing I did want to go over real quick is, you notice I have these highlighted, and that's to go over everything that's inside is pretty much every interface except for the one interface that's red. The one interface that's your serial port going from the router 1 to the ISP. So that interface, that serial 000, is outside. Everything else is IPNet inside. We have step 7 and step 8, which are configure default routes from R2 to ISP and advertise the default route to R1. It needs to say R1 and R2 here, because R1 is the one that's connected to the ISP, so it wouldn't make any sense for us to have it on R2. Lafayette R1, And what we're going to do, exit out, IP route. So we're doing static route, right? It's supposed to be IP routing. Okay. Simple. Default route, which is step 7. Configure default route. Okay. That's literally just all zeros, and then the address of the next hop address. For us, the next hop address is this port right here, this serial port on the ISP, which is 64.2.2.2. That's step 7. Step 8 is to advertise the default route to router 2. Well, all that requires is us to type in router OSPF 10 again, and then default information originate. Remember, your best friend is going to be what? It's going to be the question mark if you get lost or confused. Config T, IP routing. I throw that in there. I don't care, Dale. Doing it anyway. IP route 0.0.0.0.0.0.0 64.2.2.2. Boom, IP route's done. Immediately go into router OSPF 10, and then from there, default, I'm just going to type DEF, click tab. It immediately fills out information. I'm going to hit question mark. There's only one option there, so it's originate. I can literally type ORI, originate, enter. That's done. Exit, exit, read write. That is done. Step 7 and 8 is done. So now we have a default route on here, and it's going to this router through OSPF. Cool beans. Step 9 is to configure static route on ISP to reach all networks on router 2 and router 1. So what does that mean? That means, well, even though we are OSPF acknowledged that this exists, we don't have OSPF set up over here. So on the ISP, we need to create routes to all of the networks that exist in LAN 1, LAN 2, LAN 3, LAN 4. All the ones that are connected to router 1 and router 2. So to do that, quite simply, all we're going to do is go into the ISP. As you can see, I have 5 routes. So we'll see why I have 5 routes in a second. For this router, you've got this network, this network, this network, this network, and this one right here in the middle. So that's why we have 5. That's done. So now, at the very least, this server can ping anything over there. So let's try it. Ping 64.2.1.2. Boom, there you go. That server can see clearly now. The rain is gone. You start with the address where you want to go, or the network, network ID of where you want to go, the subnet mask of where you want to go, and the next hop address. So if I'm at the ISP, my next hop address is this other side of the serial port, which is 64.2.2.1. Step 10. What is the cost from R1 to LAN 4? Okay. What is the cost from R2 to LAN 4? Okay. That's what this should say. So R2 is over here. It's connected to R1 by a gigabit connection. So the cost there is 1 normally. However, what did we do? We made that cost 10 earlier. So the cost is actually 10, and then the 1 down here, so it makes it 1. The connection between these two is 1. Boom, bada bing, bada boom, cost would be 11. If we were going to come this way, you'd have to add in the serial. Serial is 64, I believe. So you'd have to add 10 plus 64 and then plus the 1 right here. So anyway, costs, very simple. Test your work and fix ISP side routing. So right now, if I'm this server and I try to ping any of these computers, I don't believe it's going to work. So we're going to try it. Ping 204.2.24.2. As you can see, it's not working. So we're going to solve that by giving some routing to ISP router 2, which is this router right here. We haven't done anything to it. So we're also going to add routing back to the ISP as well. So first thing, go to ISP. We're already in config mode, so we're going to copy these 2 IP routes. Again, these are just the network IDs and subnet masks. Boom, that's done. So now the ISP router has the information for these networks. And now we need to wake up the ISP router 2 that doesn't have any information. So we're going to come in here, copy this. Again, I'm doing IP routing, but we're putting a default route. So any traffic that comes to it, it goes to the next top address, which for us is 64.2.0.1. Connection right here, 64.2.0.1. That's this one right here. So that's my next hop. I didn't do static on that one because he said we were going to do default. Basically, we default route from this router in and this router in. So they're both coming in with default routes. Click on my server. He should now be able to see his buddies over there. There we go. Now I can see it. Okay. Like I made me look like an asshole. See, I can see the gateway. I can see that computer. Let's go ahead and type in 34. That's this computer down here. All right. So now this computer can see these guys. So let's see if these guys can see those guys. Yeah. Sure enough, there you go. Bada bing, bada boom. I can ping it. All right. So all my pinging is good, which is good because we're going to turn it off in a second. All right. Next thing we're going to do is block all private addresses on the ISP. So this is the part where you have to remember these 3 lines of code. Access list deny the 192.168.0.0, 172.16.0.0, and 10.0.0.0. You have to remember these 3 and their wildcard masks. So boom, now my access lists are in. Again, the command is access-list and then give it a number. I gave it 20. And then we're going to deny anything that's coming in from these address networks. Then after that, we always put our permit any. And then once we've done the access list, we've created it, right? We got to tell it where to go. So we're going to put it on interface S0/0/0, which let's look at that real quick. That is this connection right here from the ISP, right, to the router 1, right? So that connection is S0/0/0. We're going to tell it, hey, anything coming in to that connection, use this access group, which we created right here. So it goes from access list to access group, but your number remains the same. I try to ping anybody in my network, not a problem, right? Let's try to ping the ISP, 64.2.2.2. Sure enough, destination host unreachable. So what is step 13? Step 13, test your work, make sure they're all blocked. Guess what? We just did that. Step 14, apply dynamic NAT pool for LAN 1 and LAN 2 on LAF R1. So this 1, 2, and make that 2. Okay. So dynamic NAT pool, what does that mean? Well, that means that we have a bunch of IP addresses, public IP addresses, that we can use at our discretion, yeah, to do whatever the hell we want. So /28 is the subnet mask. As you can see right here, it's /28. Okay, /28 means that there's 16 addresses. We take 2 away as always, which means there's 14 available. We remove 2 of those addresses that are available for the serial port addresses we've already used, which is .1 and .2. That leaves us with 12 addresses. Now we want to put a static address on this server later, so we take one of those away. We're going to give that .15, which leaves us with a pool of 11 addresses. So our address pool is going to be 64.2.2.3 going to 64.2.2.14. Okay, now I'm going to copy this. Now is match our drawing, if that's all right with you guys. Go ahead and put that in here. Boom. That's going to be dynamic NAT pool. Okay. And the one thing you did notice, and you noticed correctly, is I don't have that server in here. So we're going to add that server in. .224, which is /27. 172.16.12.1. Now, that's where our dynamic NAT pool is going to be. Alright, what is our dynamic NAT pool going to consist of? It's going to be 64.2.2.3 to 64.2.2.14. Okay. Alright. Now, we'll go back down to the steps here. Step 4, on Lafayette router 1, we're going to copy this code. What is this code? IP NAT pool, because we're doing a pool. calling it Shrek. And what addresses do we want to use? .3 to .14. What is the subnet mask? Boom. Right click, paste. Boom. Okay, so that's done. Now what else did we do? Well, we made the pool, right? And then we got to say who can go swimming at the pool. We say access list 20, and then permit, or who we letting in the pool. And we're letting in LAN 1 and LAN 2. So we use the network ID, so it ends in .0 or .32, and we use the wildcard mask, which is this 31 that you see here. So that's it. Access-list 20 is the number I gave it. Right? Now, we've made the pool, built the pool in the backyard, got your list of who's allowed in. Now you got to say enforce it, right? So you say IP NAT inside source list is 20. This is our list 20 right here. And what pool do we want them to not go in or go in? The Shrek pool. And after that, we're good. Any computer in this area should be able to do what it was not able to do earlier because it's being translated. Sure enough, I can ping now. So what's happening is that IP address is getting translated to a public IP address that we talked about in the pool, and then we're getting all the permissions. So let's ping 204.2.24.66. Sure enough, I can see that. So we're good. Now this computer and everybody else can ping and see that. So if you're in this area, you're good. All right, that is that's 15. That's 14. Excuse me. So what is step 15? Apply PAT 4, LAN 3, and LAN 4. These networks, give them a translated address through this one port, which in our case is S/0/0/0. Right? And we call it PAT because we use the overload command, which means they're going to assign different ports to every single one of those connections. So this is NAT, but this is PAT now because we put overload on there. And there's, from what Mr. Sharif said, there's really no scenario where you wouldn't use overload. You would. So very simple, same concept. We have to make a list to let everybody know who to let in, right? So we're gonna make our list like Santa Claus. We're gonna check it twice. And what are we letting in? Well, we said networks, right? We're gonna let in this LAN and this LAN. So you can see here, I've got the network ID and wildcard mask for LAN 3. I've got the network ID and wildcard mask for LAN 4, excuse me. All right, router 1, paste. Boom, that's done. So now, that means any of these guys should be able to what? Ping anybody over here. Sure enough, I can ping them. So the translations are working. Step 16. Apply a static IP address to Lafayette R1 for LAN 1 server. So I want to have LAN 1 server have his own address. And like I said earlier, we're going to give him 64.2.2.15. Okay, simple enough. Again, we're coming back into Lafayette router 1. Why? Because this is the one that's connected to the outside, right? And we're going to basically say IP NAT, and then again inside, and then our source this time, instead of it being a pool, instead of it being a list like we did earlier, we're going to do static. So we say it's just this one address, and we're going to tell it the IP address that we want to be the static, the one that we're using, the actual computer, right? And then this is what we want it to be. That's this address right here. Right click, paste, boom, that's done. So now if I'm over here, let's say I want to ping that server, and guess what? I typed in the wrong address. It worked. 64.2.2.15. Sure enough, it found it. Now step 17, write an ACL to deny PC4 and PC5 from ICMP pinging ISP server. So this is what he said, was that he was going to have ACL on this right side of our topology here. We're going to have ACL over here, and yes, we do have ACLs on the left, but he said he was going to have it specifically on the right. I don't know if he's going to do that or not, but that's what I'm going to go with. So write ACL to deny PC4 and PC5 from ICMP ping ISP server. So now that was very specific, right? There wasn't a LAN, so I need the actual IP address of those computers. So we're going to go into router 2 because that's the one they're connected to, right? And we're going to say what? Access list, I called it 101, doesn't matter what you call it. Deny, and then we put ICMP, which is also pinging. ICMP and ping are the same thing. And then because I'm not using a network ID, I'm putting the word host first and then the host IP address. And then I'm blocking a specific IP address, so I also again put host and a specific IP address. Permit ICMP any at the end of that. Now our list is done. Now we got the list to give it to the bodyguard. We got to tell the bodyguard where to stand, right? So what I did was I put it on both of these connections. I put it on both gig 01 and gig 02 because I want it both there. I want the bouncers both there watching, right? So I'm on here. I'm going to copy this, enter, right click, paste. Boom. There you go. There's my access list. There's everything I needed to see. I also didn't get this done right. This is going to be on ISP 2. Okay, so access list, give it a number between 0 and 200, and then you're going to deny in this case. What are we denying? We're denying the ping function, or ICMP, of what? Either a network or a particular host. In this case, a particular host. And what are we denying them to do? Ping this computer. So now, if I come in here to PC5, I should not be able... Oh my God, I hate you so much, packet tracer. Okay, let's ping it. So we're going to try and ping 204.2.24.66. And there you go. It says destination host unreachable. I can't ping it. I don't have permission anymore. Let's try and ping the other computer, 34. I can ping it, no problem. Let's try and ping something on the other side of the map, 172.16.12.2. Sure enough, I can ping it. So that's all fine. I can't ping that server now. ISP LAN 1. ISP. Same concept here. We're going to be on router 2 on the ISP side. And we're going to make our IP access list. And we're going to use extended because we want to give it that particular port that we're blocking. Okay. So because it was ICMP earlier, we weren't using a port technically. This time we're using a particular port. So we're going to use extended. So I need to be in config T. Copy, paste. Okay, so what do we do here? We said deny UDP because I said we wanted to block FTP, so that's using the UDP command instead of TCP. And what do I want to deny? I want to deny this LAN, so this network. Okay, I want them to deny what? I want them to not be able to touch this host, so a particular computer, not a network. And then on what? EQ, and then what port? 20 and 21. Those are the two that we're using for FTP. Put that in. Don't forget your permit IP any. Hit exit. Do read write. Made our list. Checked it twice. Now where do we got to put it? We got to tell the bouncer where to stand. So we come look at our map right here, and we're only blocking LAN 1. So we're blocking this guy. So we only have to put the bouncer standing right here. So that's why we only chose gig 0/1, and then IP access group, and then what I called it specifically, capital letters, everything, deny FTP, and then in. Why? Because they're going to be trying to get in right there, and you're going to block them and say no. So that's done. Step 19, our final step, is we're going to permit LAN 2 and deny LAN 1 from HTTPS of LAN 3. So I want to block LAN 1 from being able to HTTPS into LAN 3, and I want to allow LAN 2 from being. I want to allow LAN 2 and block LAN 1. So big chunk of code here. Same concept though. IP access list extended again because we want to use specific ports. And then what do I want to call it? Deny HTTP. You can also just use numbers if you'd like. This time, instead of saying UDP, we're saying TCP. So deny TCP. And then what am I denying? I'm denying a whole network, a whole LAN. So I've got the network ID followed by the wildcard mask. And then I want to block it from going to a whole network. So I have the whole network ID followed by the wildcard mask. And then what are my EQ? If you get to EQ right here, we're going to go through it just so you guys can see. Don't forget your question mark. IP access list extended, and we're going to call it deny HTTP. Now, deny TCP, we're going to type in 204.2.24.0.0.0.31, and then 204.2.2.24, that's too many, 24.64.0.0.0.31, and then hit question mark, and you see we can do EQ. EQ is for port number. Okay, EQ, and then question mark, and it gives us examples. We can actually type in a physical number, or you see we can type FTP there, we can type POP, SMTP, Telnet, or in our case we're going to use www. And then hit the up button, and all you change is this last part. We're going to type 443 for HTTPS. And that's done. That's done. Now we're going to copy the rest of this, which is the permit. Exact same thing, just the opposite direction, right? Now, what else are we doing here? Well, we also are permitting, right? Like we said, we're going to permit that other LAN. We're going to permit LAN 2. And then we also have to throw in our permit IP any. And then we're going to exit, do a read write. And then again, we've got all these lists. We want to tell the lists where to stand. So we picked both interfaces and we put the list on both interfaces. Now, if you wanted to, you could make two separate lists. I just did it all together because I don't care. So now if I try to HTTP, technically it should stop me. Let's see. It was all glitchy earlier, so I don't know if it's actually going to work or not. 204.2.24.66. Oh, there you go. I can see the website. Cool. So PC4, which is on LAN 2, can see it, which is good. What happened to you, man? Get your ass over here. So now, hypothetically, if I take this PC and try it to web browser, it should not work. Also, we didn't try FTP, but we'll do that as well. Okay, so he should not be able to 204.2.24.66. Alright, there you go. You see he can't get to it, but he can. So that's done. That's done. That's everything on the list. Request timeout. Beautiful. So let's check FTP, the FTP real quick. So we denied LAN 1 from being able to FTP into this server, right? So this computer should be able to. So let's try it. Come here to command prompt on both computers. I did not click on you. Command prompt. Okay. Type in FTP 204.2.24.66. That's PC4 right here. That's LAN 2. I should be able to do it. Check your LAN. Check your FTP information. Come here to the server. Click FTP, and there's your password and username. Cisco. There you go. Anyway, that's it. I'm gonna upload this right now and be done with it. Bye bye. Good luck. Thank you so much for watching this video. I want to shout out my Patreons from Patreon, and my new YouTube members as well. I got that going. Appreciate all of you. Thank you so very much. Your help has been crucial to keeping me alive and keep streaming and keep helping and hopefully entertaining you along the way. Anything I can do to make it more worth your while, please let me know down below. Also, you can find me on my Discord. I have my Discord server link down below, Patreon links down below, and then membership should be somewhere around here. Thank you all so very, very much. I really appreciate you. And I look forward to the future, and I hope you will come along for this journey with me. Thank you. Take care.